Okay, lesson 1.7 is on transformations of functions. By transformations, we're talking either shifting, which is up, down, right, left, reflecting, either across the x-axis or the y-axis, and then we also have stretching and shrinking, either towards that y-axis or away from the y-axis. We'll get into that probably on day 2. So let's look at shifting for right now. Take our parent function f of x equals x squared. And we want to graph this function. And when we graph it, rather than sketching, if we're graphing it, we're actually putting in some points. And so I know when x is 0, y is 0. When x is 1, y is 1. When x is 2, 2 squared is 4. When x is 3, 3 squared is 9. So this is enough points. And we also know that the negative x's work as well. So this is a parabola that has these spots. I'm going to try and sketch it or draw it as best as I can. So, okay, so this is f of x equals x squared. Now, let's say we wanted to shift it. We'll call it, we're going to do it in red. We'll call it g of x is equal to, let's say it's x squared minus 2. We know that the negative 2, because it's outside of any parenthesis, it means you shift it down 2 places. And so the easiest way to do this, to sketch it, is each point on the coordinate plane is shifted down 2 places. So we'll just draw our lines in, and each one is shifted down 2 places. And then we redraw this as our g of x, and this is a vertical shift down 2 spots. So let me see if I can draw this. Now in this section, you're going to be using the same coordinate plane to draw 2 or more graphs. And so what you want to do is either use colored pencil, or what some students do is they'll draw it in pencil and then they'll go in later and highlight in a different color. So either way works. And now we want to do, let's do it in green. We want h of x. And let's say that's x minus 2 quantity squared. This is a horizontal shift because it's inside the parentheses. And because this is a negative here, that means we're going to shift it to the right. So go back to the blue dots, move everyone to the right 2 places. So here, 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 here. And so this is going to look down like this. And this is h of x. Again, if we wanted to highlight it, we'd highlight it in a green. And also what you could do is highlight your, where you draw the equation. So then you know, just by looking at it, which color belongs to what. So let's just list the rules for shifting. So let's say we have a shift up, and that is f of x plus c, where the c is a constant. Shift down. This is f of x minus c. If we wanted to shift right, this is f of x minus c in the parentheses. And shift left is f of x plus c. So when you're shifting horizontally, it's opposite of the sign. When you're shifting vertically, this is horizontally. That's kind of, I'm going to redo that. When you're shifting vertically, it's the same as the sign. So plus is up, negative is down, horizontal. Negative is right, positive is left. All right, so what if we had a combination? We wanted to shift right and up. This would be f of x minus c shifts it right, plus k shifts it up. What about shifting left and down? Well, that'd be f of x plus c, that goes left, minus k, would take it down. Okay, let's look at reflections. They're either reflections in the x-axis or reflection in the y-axis. So let's look at a reflection in the x-axis. We'll use our f of x equals x squared. And we know what that looks like. It has the shape. It's a parabola, and it's opening up. If we wanted a reflection in the x-axis, what we would do is make it f of x is equal to negative x squared. And this gives a upside down parabola opening down. This is a reflection in the x-axis. You put a negative sign before your function. Now, if you wanted a reflection in the y-axis, we're not going to use the x squared as our example, because if you reflect it in the y-axis, because it's an even function, it's going to look the same. So we're going to use an odd function for our example. F of x is equal to x cubed. Well, what does that look like? Let's just graph it. And you don't have to graph the whole thing to get an idea what the shape looks like. When x is 0, y is 0. When x is 1, y is 1. When x is negative 1, negative 1 cubed is a negative 1. So now, if you stop there, you might think, oh, this is a straight line. Well, it's not, because if we did when x is 2, y is 8, well, that's going to be way up here. So this is going to take off quickly like this. It's going to come down here and then go down like that. So this is the shape of a cubic function. It's odd because if you rotate it about the origin 180 degrees, it looks the same. So this is an odd function. So if we want to reflect it in the y-axis, what this becomes, f of x is equal to negative x cubed. Notice the negative sign is inside the parentheses, and that gives you a reflection in the y-axis. So what does this look like? Well, it's going to look as a reflection in the y-axis. Still have a 0, 0, but this point here is going to be reflected in the y-axis. Matter of fact, every point is, so it's going to look like this. And so you're going to come down, and this is going to be what it looks like as a reflection in the y-axis. Okay, example 1. We want to graph the following functions, these functions, on the same coordinate plane. So we want to use different colors. And the first function is going to be our parent function, which is x cubed. So we're going to do that in blue. So we're going to graph, or put the dots in, when x is 1, y is 1. When x is 2, y is, 2 cubed is 8. So now this is an odd function, so when x is a negative 1, y is a negative 1. When x is a negative 2, y is a negative 8. So this is our cubic function, and we'll do our best to sketch this. Okay, so you don't have to label the graph since it's color-coded. We know that blue is the x cubed. So now we're going to do g of x. G of x is equal to x cubed plus 2. Well, we know we're going to shift this up 2 places. So we take every blue point and we shift it up 2 places. And on the left-hand side, we're still shifting everything up 2 places. So when we get 4 graphs on this, it's going to look a little bit messy, so you have to do the best you can. The red graph should be the same as the blue graph. It's just shifted up 2 places. So let me draw. Okay. Now, the green one, its h of x is x minus 2 cubed. So since it's inside the parentheses, it's going to go 2 places to the right because it's a negative sign. So we'll go back to the blue, and every dot goes 2 places to the right. So here's the one, here, 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 and here. So now we can draw h of x. Okay. And lastly, we have j of x, which is x minus 2 cubed minus 2. So we know this means it's going to go right 2 places, and this is down 2 places. So we take the blue dot and we go to the right 2 places and down 2 places on each one. So starting at the bottom blue one, to the right 2, down 2. Next one up, right 2, down 2. And the origin, to the right 2 and down 2. This one to the right 2, down 2. And finally, we have that. So now we can draw the purple one. Oops, I goofed up. Let me redo this. This point is not there. It's the blue one to the right 2, down 2. Okay, that's more better. Let me try drawing this again. So it's going to be there. Now, see how messy it looks when you get more than one graph on the same coordinate plane. So that's why you want to be really careful. Do the best you can in sketching it out and use different colors, and that'll help a lot. Okay, example 2. We're given a graph and we need to find an equation for the graph. Well, we can tell by looking at the graph, we know it's a parabola, and so the parent is f of x is equal to x squared. But what do we know about this? Well, it's flipped, so it's reflected in the x-axis. It's also moved to the right 4 places and down 2, just by looking at where the vertex is. So, f of x, that's going to be a negative because it's flipped in the x-axis, and it's moved to the right 4 places, so that's going to be a x minus 4 squared. Remember, the negative means it's moved to the right, and it's going down 2 places, so we subtract 2. And that's all there is to it. When you recognize the parent function, you can translate it up, down, left, right, based on what it looks like on the graph. Okay, so that's it for day 1, and day 2 we'll talk about stretching and shrinking.